Okay, guys, so I'm working through the last few examples from chapter 8.3, which is integrals involving trig functions and some techniques we can use to handle them. So we may have started this integral already, and basically we're relying on a half angle formula, which says that sine squared of x equals 1 minus cosine 2x over 2. Okay, or 1/2 minus 1/2 cosine 2x, or 1/2 times it. You can write it a few different ways. Okay, so what we're going to do is we are actually going to sub this out, and we get something like this, 1 minus cosine 2x over 2, and then the whole thing squared, still behind our integral. Okay, and so from here, if we attempt to simplify this a little bit, what we can do is say that the 2 squared at the bottom will come out as a 1/4. Okay, and then 1 minus cosine 2x squared dx, and then let's FOIL this out, and we get something along these lines, minus 2 cosine 2x and squared 2x. Okay, and then now at this point, we reach a stage where I have another cosine squared. Okay, and again, I can't use u substitution or anything like that. We are going to turn this back into another half angle. And here, this is just, instead of 1 minus cosine 2x, it's going to be 1 plus cosine. And now it's 4x instead of 2x, and that's over 2. Okay, now from here we also have 2 cosine 2x, and then of course our 1. We take this integral with that 1/4 in the front. Okay, so here's where some of the important patterns are kind of kicking in, and we need to keep these in mind because they will be super helpful to us. One of the most helpful ones, and I will do this off to the side over here, is the integral of cosine 2x. Okay, and so this integral, we should get pretty familiar. It is sine 2x. And because of this 2, we just end up dividing this whole piece by 2, or putting a 1/2 in the front. Okay, and if you keep that pattern in mind, that you're like, okay, if I take the integral of something, I just have to divide by that derivative of the inside piece, that 2 or that 3 or whatever is with it, and that will just help you out a lot in making your life significantly easier. Okay, so if we use that pattern, that's going to make our lives easier in this integral. Okay, let's see how it works out. So we've got our 1/4. 1 is going to become x. This is going to become minus sine 2x. Okay, now remember, this is kind of a compound. We're going to have 1/2 plus 1/2 cosine 4x. Okay, and so the 1/2 becomes 1/2 x, and we have a plus 1/8 sine 4x. And then our plus c. Okay, we can combine a couple of terms here. We can combine this x and 1/2 x, and then that's 3/2x minus sine 2x plus 1/8 sine 4x plus c, and then still times our 1/4 in the front. Okay, again, you could work this out. You don't have to do this step, but I'll go ahead and do it for the sake of being a complete answer. 3/8x minus 1/4 sine 2x plus 1/32 sine 4x plus c. And there is our final answer to this integral. Now, it can be a little tricky. There are a lot of moving parts, especially when we start subbing pieces with these formulas, remembering what's positive, what's negative, and what's going to change signs when we take those integrals is really important. That's why this trick and shortcut right here is really important off to the side. Remembering that, hey, if it's cosine 2x, when you take that integral, all that's going to happen is you're going to divide by that 2. Okay, and we can use that rule a lot in this section to make our lives easier rather than having to constantly think about, okay, I'm going to use 2x as u and du is going to be 2 dx. And you just kind of can shortcut that step and save yourself a lot of time. Okay, so On this page, we're going to talk a little bit about combinations where we have sines and cosines together, okay? And usually there's two common approaches for this. So the first one is going to be when we have both even exponents, okay? So I've kind of made a note here. Both even powers, we're going to use a half angle formula. We'll rewrite everything in terms of cosine 2x, 4x, 6x, whatever we need, and then we're going to work our way from there. Okay, so the first step, let's use our half angle formulas again, and that's going to reduce the powers of both of these expressions. So here you can see I've gone ahead and replaced my sine to the fourth and my cosine squared with these formulas. Okay, so again, this is that half angle formula, the same one we used in the previous section. Okay, so with this, okay, we've now made everything kind of the same sort of term. Okay, and that's going to make our life a lot easier. Okay, let's start by cleaning this up. So here, this is like a 2 squared, right? So that's like a 4 in the denominator. This is a 2. Let's pull that out in front as a 1/8. Okay, again, pulling this out just makes our life significantly easier in the long run. So we have something like this, 1 minus cosine 2x squared times 1 plus cosine 2x dx, integral 1 over 8. Okay, now what we're going to do is we are, of course, going to FOIL all of this out, which gives us something along the lines of what I have written here in black. Okay, so at this point, you would think you're like, hey, this still looks very convoluted, but there is some good news. If we kind of split this into two parts, okay, we actually find two integrals that we know how to solve. I finished solving this problem on the next slide because there is not a lot of room here. You may need a piece of scratch paper, as this problem does get pretty involved still. So the trick to solving this integral, and I took some extra space because I want to be able to show you all the steps, is going to be to split it into two smaller pieces. So right along here. Now, the thing is, these pieces individually are still pretty convoluted integrals, okay? So what I'm going to do is I'm going to take the integrals and then I will save this 1/8 until the very, very end and multiply everything by 1/8, okay? However, these are fairly complex integrals in their own rights, okay? So let's start with this left half, okay? 1 minus cosine 2x. And what we'll do is we will substitute out cosine squared 2x for 1 plus cosine 4x over 2. Okay, and what we're going to do is we're going to take this integral first. Okay, and then we'll do the right hand side, which is the cosine cubed with the 2x. So starting, let's just take the integral of all the pieces and then we'll simplify it afterwards. Okay, so 1 just becomes x minus cosine 2x is going to become sine 2x over 2, okay, minus, we have a 1/2, that's going to be 1/2 x, and again, this is splitting this up, and then minus sine to the 4x over 8. Okay, remember we're kind of using the shortcut where if there's a number inside, it just kind of divides down underneath there. Okay, and then remember all of this is going to be times 1/8. Okay, now don't be afraid of working these pieces out individually. I'm kind of shortcutting through them in the interest of saving a little bit of space here. But this technique is the same one we used in a previous problem. Okay. Now let's look at the right-hand side of this, the other part, which is cosine cubed 2x. Okay. So to take the integral of this, let's make it cosine squared 2x times cosine 2x. Okay, and this is going to allow me to use a Pythag identity here, make this 1 minus sine squared 2x cosine 2x dx. Okay, and what we'll do is we will use the sine as our u and cosine as our du, right? So here we go. U is sine 2x and du is 2 cosine 2x. Okay, so notice we are missing this 2, which is kind of important. So what we will do is we're going to put a 2 here and a 1/2 in the front. Okay, and our integral looks like this: 1/2 integral 1 minus u squared du, which is not so bad. We get something like 1/2 u minus u to the third over 3. And let's sub it back out and clean it up a little bit. We get 1/2 sine 2x minus 1 over 6 sine cubed 2x. And then all of this is still times the 1/8 from the beginning of the problem. And now all we're going to do is we're going to put everything together. So I will write all the terms out first to the side, and then we can try to combine whatever makes sense. So 1 over 8x minus sine 2x over 16 minus 1 over 16x and minus sine 4x over 64. Okay. On this side, if I distribute my 1/8, we get something like, and I'll put them as fractions to match the other side, sine 2x over 16 minus sine cubed 2x over 48, right? You'll see that we do have some pieces that can combine together, like our x terms right here, and of course we have the sine 2x's plus and minus right here. So those actually end up canceling each other out, okay, which is nice. So here's what our final answer ends up looking like. 1 over 16x minus sine to the 4x over 64 minus sine cubed 2x over 48 plus c. And that ends up working out as our integral. Okay, so now you can see we ended up doing a ton of work for a single integral, which started out fairly simple, right? And we split it up and we said, okay, we can take this piece and break it down into smaller pieces and take that integral. So this process is very involved, okay? But if you keep in mind what your end goals are, you can come up with this without it being too overwhelming.